Welcome! Today we're going to unlock one of Python's most useful built-in toolkits, especially for anyone just starting out with data, the statistics module. It's absolutely perfect for when you need quick, solid calculations without needing to install some huge, complicated library.
So here's our game plan. We're going to start with why this little module is such a big deal. Then we'll get our hands dirty and actually import it. After that, we'll dive into the core stuff, calculating the mean, median, and mode. I'll also show you a really neat shortcut to make your code cleaner, and then we'll wrap it up by getting you ready to try all this out on your own.
All right, to really get why this module is so handy, let's start with a situation that I'm sure you've run into before.
Okay, picture this. You've got this list of test scores. Just looking at it, what does it really tell you? Are the scores good, bad? Are they all pretty close together? It's really hard to get the story just from a raw list of numbers. We need a way to summarize it.
Now you could, I suppose, write your own Python code from scratch, with loops and counters and all that stuff to figure out the average. But honestly, why would you want to reinvent the wheel when Python gives you a much smarter, faster, and way less error-prone way to do it?
And that way is by using a module. The best way to think about a module is like a specialized toolkit. Python comes packed with these, and today we're grabbing the one that's built specifically for statistics.
Okay, so let's see how we actually bring this toolkit into our code. Whether you're in a Jupyter notebook or a regular Python script, it all starts with one simple line.
First things first, we need the data itself, right? So we'll start by making a classic Python list. We're just putting our numbers into a container and giving it a name, test scores, so we can use it later. This is our raw material.
And here it is, the magic word, import. This one little line, import statistics, is like opening up a toolbox. You're telling Python, hey, go find that statistics toolkit and make all of its functions ready for me to use. Just like that, our program now has statistical superpowers.
So, quick gut check. To call a specific tool from that toolbox, say the function to calculate the average, what do you think goes in that blank? It's mean. You always use the pattern module name dot function name.
Okay, our toolkit is ready to go, so let's do some actual analysis. We're going to start by trying to find the center of our data, and we'll look at 3 common ways to do that.
First up is the mean. You definitely know this one. It's just the good old average. It gives us a really solid idea of the central value in a set of numbers.
And just look how easy the code is. We use that same pattern, statistics.mean. Then, inside the parentheses, we just pass it our list of scores. That's it. Python is now doing all the adding and dividing for us in the background.
And boom, there's our answer, 81.6. In a split second, we went from a kind of confusing list of numbers to one single value that tells us something meaningful about the group's performance. That's the power of using a module.
Next up, we've got the median. This is the true middle value. Now, why is this so useful? Well, imagine one student got a really low score, like a 10. That one score would drag the mean down a lot, but the median, it doesn't really care about extreme outliers. It just lines all the numbers up and finds the one smack dab in the middle, giving us a more stable sense of the center.
And yep, calculating it is just as easy. The statistics.median function does all the heavy lifting for us. Behind the scenes, it's sorting our scores, 67, 78, 85, 88, 90, and it just plucks out that middle value, 85. We get the answer without having to do any of the sorting ourselves.
And finally, we have the mode. This one is super straightforward. It just tells you which number shows up most often. It's the most popular value in the set.
Now you might have noticed our first list of scores didn't have any repeating numbers. That means it has no mode. So, to actually see this function work, let's use a new list where the number 83 appears twice. When we run statistics.mode on this new list, it correctly tells us that 83 is the most common score.
All right, so knowing the center of our data is great, but it's only half the story. We also need to know how spread out the data is. Plus, I'm going to show you a little shortcut for importing that can make your code a bit tidier.
This is where standard deviation comes in. It's really just a way to measure the spread. A small number means all the scores are bunched up really close to the average. A big number means they're scattered all over the place. And of course, we can calculate it easily with the stdev function.
Now check this out. This is a really cool style shortcut. On the left is what we've been doing so far. Import statistics. It's great because it's super clear where your functions are coming from. But on the right, there's another way. You could say, from statistics, import mean, stddev.
This lets you import only the specific functions you need, so you can call them directly without typing statistics dot every time. It makes the code a little shorter. Both ways are totally fine. It's just a matter of preference.
So we've covered the tools and we've covered the techniques, but now for the most important part, how you can actually put this all together and use it yourself.
And this is the basic workflow you'll use again and again. It's a simple recipe. Step 1, get your data into a list. Step 2, import your tools. Step 3, run the calculations. And Step 4, and this is the most crucial part, take a second to actually interpret what those numbers are telling you about your data.
Okay, now it's your turn to really make this stick. Find some data from your own life. Seriously, it can be anything. Your grades, your daily screen time, lap times from running. Just put those numbers in a Python list and then use the statistics module to find the mean, median, and standard deviation. And for a little extra challenge, try using Python's built-in max and min functions to find the highest and lowest values too.
The statistics module is really your gateway. It's the perfect first step into the huge and powerful world of data analysis with Python. It's the tool that helps you turn a boring list of raw numbers into a real story with actual insights. So go on, find some data, start exploring, and see what you can uncover.